Today, inshallah, we will start chapter number 4 from our book. And chapter number 4 is on hardware description language. In short, it is called HDL. HDL, hardware description language. How many of you already taken C? Already finished C course? Taking C or no? This semester? You are taking?
Yes.
All of you? Who did not take C? You did not take C? What? C language, programming. You did not start it? No, I mean,
I didn't take.
you didn't take it?
Yes.
When you will take? Next semester?
No, maybe.
Then it will be a little problem. Because this is a programming. It's programming. So you need to know the knowledge of programming. Anyway, let's see what we can. So in hardware description language, what we do is,
Chapter 4.
yes, it is chapter 4, that we describe the hardware by typing. Okay, and there are software that will automatically generate the circuit diagram. It can minimize automatically and generate the circuit. All you need to do is to give it the function, tell the function in terms of AND or NOT, XOR by typing it in some language, and by software you can get the diagram for implementation. Do you understand? So this is not same as chapter 2 and 3. Chapter 2 and 3 we learn how to design circuit and other things. Here little different topics. We will learn some syntax like your C programming, how to write some module, how to calculate some operation. Okay, and by using a software which I will show you inshallah, you can get the diagram, schematic, the circuit. Do you understand? So these are the topics we will see. So two main HDL are Verilog and VHDL. VHDL is a very long thing. Who will use VHDL? You can see it is developed around 1984 and this is 1981, around the same time at different groups. Both of them are used. Okay, both of them are used, and in your book, in this chapter, every example they put Verilog on the left, VHDL on the right. Both of them are in your book. You understand? For each example, they have both Verilog code and VHDL code. But we will see only Verilog so that we understand it. And in the future, if you need to learn VHDL, you just need to look at the syntax. You understand? Learning both of them together, it may be difficult for you. So we will see examples for Verilog. Okay, the same thing you can do using VHDL also. And the software I told you, that in the software you can either use Verilog or VHDL. The softwares for generating the circuit, they support both Verilog and VHDL. Okay. So the software that we use is called Computer Aided Design Tool, CAD. design used for designing the hardware. So two terms you should know. One is called simulation, another is called synthesis. Simulation is, say I want to make a circuit. Okay. Say the problem we solved, the traffic light problem. Remember the traffic light problem we solved in our class? Finite state machine. Say we want to solve it, and we want to find the circuit using software. Now, in the simulation, when you write your code, in the simulation, the program will give the input, it will calculate the output and check for errors. Do you understand? Like, if you want to check for error, what you can do? You can implement using hardware, give input, check output. But sometimes you don't have the hardware, right? Sometimes you need some hardware that is very expensive, right? Do you understand? Sometimes if you want to try, you want to make a circuit. Now the circuit, you may not have the hardware, or it may be very expensive. So how can you check it? So one of the things is simulation. In the software, as if you implement in the software, it will test without the real circuit. Do you understand? Yes. So this is called simulation. That it will give input, it will check the out, it will compute the output using your function, and it will check for correctness, and by this you can save a lot of money. A lot of money, time and money. Okay. And in the synthesis, your HDL code will be transformed into a circuit diagram, not a physical circuit. Physical circuit you will make. The software will show you a diagram, right? The diagram we draw by hand, and gate or gate. The software can generate this diagram for you. This is called synthesis. Okay. And you should remember here that when we are working with HDL, actually it is not like general programming. In general programming, we write many statements like print, right? In the C, yes. You have scanf, printf, right? Already you know. Printf, you print on the screen. Scanf, you read from the screen. Now, for hardware, what is printf? If you think about hardware, printf, printing on the screen, does not mean anything. It may be in the simulation that it will print the results and something. But for the hardware, printf, scanf, as a general programming, it is not possible for hardware. Okay, so HDL, yes, it is a language, but it is a language for hardware. It is not a general language for programming anything. You understand? We are designing a hardware, and we will describe the hardware by a language, and this is called HDL. Okay, so let us try to start. So we will, as I told you, we will look about Verilog, right? We will study, inshallah we will study Verilog. VHDL you can study if you want, but all the examples we will see is for Verilog. So again, you can think about that your HDL code is here. You have some input, say ABC, and you want to calculate the output. Now, in chapter 2 and chapter 3, we design these circuits. Right? We design these circuits. Now, here we will write code. We will write code for this box, for this module called Verilog module. So Verilog module can be two types. One is called behavioral and structural. Behavioral means you need to tell the function like A and B and C, or AB or CD, like this function. You need to tell it here. And in the structural, you connect this module with this module with this module to get the result. We will see both, inshallah. So let us see examples, it will be clear. Okay. So how to write a behavioral Verilog module? So can you see this word?
No.
Not very clear. Right? It's module. Written here, module. Module. This word. Module. So this is a code you write in a software. There are several softwares that you can use. I will show you some. So this is how you write. Module, then example is the name of the module. Example is the name of the module, like the function name in your C. The function name in your C, it is similar thing. They call it module. It's like a function. It's like a function. You give input, it will return you the output. Okay, it's like your function in programming. But here we call it module. Module, function, block, they are similar name. Okay, similar name. So module, here you give the name, example. Now you have some input, you have some output. So the inputs you write like input A, comma, B, comma, C. So it means A, B, C, they are inputs. Okay. How many bits? Remember, in hardware we are giving bits, right? And we will get also bit as output. Boolean input, Boolean output. So how many bits here?
3.
ABC, yes. ABC is 3 bits, but A is 1 bit, B is 1 bit, C is 1 bit. Output Y is also 1 bit. Okay. Now module will finish with end module. So module, with the word module you start your module, and the word with the end module will mean the end. Like in for example in C you write within 2 brackets. In other programming language we finish by the word end. Okay, so different language has different ways. Okay, so here we do not have these brackets, we have end module. End module will mean the module is finished. Okay, so between module and end module you write your program. Okay, so here y equal to this, a function. So actually this means y equals, this one means not. I think in C also this means not. This one means not. Okay. This one means and. This one means or. There are others we will see. So y equals A bar, B bar, C bar, or A, B bar, C bar, or A, B bar, C. This is you know, right?
Yes.
This is familiar, you know, from your chapter 2 and chapter 3.
Yes.
A bar, B bar, C. Here this is and, right? This is or A and B bar and C bar. Or A, B bar and C. So this, if I give you this, and if you want to write it in Verilog, if you write it in Verilog, you know in computer it is difficult to write in the top, right? How can I write A bar? A with a bar. It's not easy, right? So yes. So what we do, we put this one, this one. So this A bar means this, not A. And here actually we have end, right? This is end. This is end, right? So A bar and B bar and C bar. Plus means or. Here or is given by a line. In the keyboard we have this thing, right? You know, in the keyboard we have this character, keyboard. So A and B bar and C bar, or A and B bar and C. So this is the function, Boolean equation we write here. Okay. But for Verilog you need to write one extra thing is called assign. Assign means copy. So you write this one here, and at the beginning you write assign. Assign means evaluate and copy the value into y. Okay? So this is how you write module in Verilog. Now what you can do is using software you can generate timing diagram. You can generate the timing diagram for the module. Like you can generate the value for say A, value for B, say some B, value for C, and the result Y. The timing and the timing diagram. Say here again Y is A bar, B bar, C bar, or A, B bar, C bar, or A, B bar, C. Right?
Yes.
So you can see here Y is high A, true here, because in this part, see here A is 0, B is 0, C is 0. 0, 0, 0. If you put this one will give you 1, right?
Yes.
That's why output Y is 1 here. Again 1 is here, right? A is 1, B is 0, C is 0, right? 1, 0, 0. So 1, 0, 0. Which one will give you?
How 1?
Yeah, see, it's timing. This is 0. This level is 0.
Yes.
This level is 1. So which one will give you high? Yes, this one, right? A, B bar, C bar will give you 1. A is 1, B bar is 0 means B bar is 1. C 0 means C bar is 1. So this mean term, these are mean terms, right? A, B, C. So these are mean terms. So this one will give you 1. So in this way, you can calculate the plot of Y. You can calculate the plot of Y. And this is generated by software, it is not written by hand. You understand? This picture, it is from a software. It's a software, not by hand. No, not by hand. It's a software. And we will show you the circuit for this, also generated by software. For example, this one, you can draw the circuit, right?
Yeah.
If I give you this function, you can draw AND gate, OR gate, right?
Just
But you can use a software, you write this code,
yeah.
you write this code, you just run the software, it will give you the diagram. Okay? See, this is the diagram. Generated by the software. We will see some software, how to use it.
We'll go to the lab. We'll use it in the
In this class, maybe I will show from the machine. Okay, and if we have chance, we will go to the lab also to practice something. Okay, so we will see each other. We will see if we can do it. So this is a diagram, the schematic or the circuit for this module generated by program. Okay, you can see here. This one is not exactly same as this, because the software minimized the equation, minimized it like what you do using K-map, and then it draw the circuit. You understand? It minimized it and draw the circuit. You can see here there are two AND, but you can see only one AND gate because minimize it. This function, actually this is, you can see here, this is, here you will get B bar, C bar. Here, A, B bar. Okay, so here you have B bar, C bar or A, B bar equal to Y. Okay, which is not same as this, right? But you can reduce this equation into this by Boolean algebra. We can try. We need Y equal to B bar, C bar or A, B bar. Okay. A, B bar is very easy. You can say A, B bar. You have A, B bar, A, B bar. If you take common, C will go.
Yes.
But what about this? We need B bar, C bar. What you can do is, say, you can write A equal to A or A, right? A or A is same as A. Yes. Right?
Yeah.
So here I add extra A, B bar, C bar. Extra. A or A is A. So if you go from left to right, A is same as A or A. You can bring an extra A, no problem. It will not change the result. So I have one A, B bar, C bar. I put another one. Result will not change. Now you can common from here. You can take common from here. Right? From the first part, common is B bar, C bar. So B bar, C bar, you can take A bar or A. And from here,
B bar, C bar.
A, B bar. A, B bar is common. C bar or C. So now, this one is 1, right?
Yes.
This one is 1. So here, from here you have only B bar, C bar,
Yes.
and from here you have only A,
B bar.
B bar. So see, this one and this one is same. So now you see how your life becomes easy, right? How your life has become easy. All you have done is you wrote this line, and you clicked some button. You click some button and you got a circuit which already minimized for you and give you the diagram. That's why now most of the commercial circuits, they do not design it by hand, everything. They design through this kind of software. Okay, use this software for testing that everything is correct. Generate the circuit, then when everything is finished, they go and implement it. It will save your time and it will save money. Did you get an idea? Did you get an idea? See? But to design this, you also need to know digital logic and everything, because you will design the problem, the solution. But this software will help you to find the circuit. Okay, but as a computer guy, you need to know the digital logic, the function, how to solve a problem, how to find the equations. Then you use this software so that you save your time. Okay. Is it clear, this example?
Sure.
Clear? Sure. Now, you know, for every programming language, you need to know some rules, what you can do, what you cannot do. Like, for example, the Verilog syntax is case sensitive. Case sensitive means A and A, they are different.
Yes.
Okay, this means K is sensitive. Capital A and small a, they are different. Okay, so they mean two different variables, two different input or outputs. Also, you cannot start a name with number, like 2 marks. At the beginning, a number means it is not allowed. The software will give you an error. Like here, input A, B, C, you give the names, right? These are the names, A, B, C. So here you cannot say 2A. Okay, you can say A2. Say input A2. Okay, no problem. But say A2, 2A. Which one is correct and which one is wrong?
That's correct.
This one is correct?
Correct.
This is correct?
Yes.
Yes.
Okay, this one?
Correct. Yes.
Correct. Are they same?
No.
No, because I told you A and
Capital
big A,
A.
small a, that's different. So this is one input, this is another input. This is?
No.
This is a problem because it starts with a number. It starts with a number. So you cannot start with a number. Okay. White space ignored. White space means space. Like you can write like this. You can write like this, or you can write like a big space here.
Ignore.
It will ignore it. No problem. If you put big space, no problem. Because sometimes say here we put a space to make it nice, so that you read. So extra space here. You see, module is here and module is here. But here you put an extra space. Why? So that you can read the code easily. Okay. But for the program, it will ignore it. It will not use this space. The extra space, it will not use. So this is called white space ignored. Comments. Comments, it's not very clear here. See, double slash, slash, star, star, slash. It is same as which language?
C.
C. Same as C. It is same as C. This double slash means a single line comment. And if you need multiple line comment, you use slash star and with star slash. So it is same as, the comment is same as C. Okay. Actually, all of them are same as C, except this one.
Same as.
Same. C is case sensitive.
Yes.
I don't
A
see.
capital is different to
No.
different.
Different? Check it. C is case insensitive, as I remember. But check. But in C also you cannot start with number. In the C also you cannot start with a number. And white space is ignored. Actually in most, if not all programming language, white space is ignored. They don't care. Comment, different language different. Java and C, they use this thing. Also in Java, same. Double slash, single line comment, and this is for multiple line. It is also in Java. Okay. Now, you can use one module into another module. This is called how you describe the structure. I think we need to reduce the contrast. It will take more time. the light. But the video will not get this. This is the problem. Okay, I will.
The light.
Okay, off, put it off. Okay, so here you can see one module, another module, another module, 3 modules. 3 modules. The first module is module N3.
Why at N3?
N3 is the name of the module. You can give any name, but not start with number. You can give a name, and don't put space in the name, like my module. A name, no. You cannot put space. You can write my module. Okay, like this. You understand? So this is the name of your module.
So teacher, you say it's ignore the space.
Ignore the space.
The beginning
So,
of
But okay, good question. You have ignore the space. It's good, but not every space. For example, say if it ignores this,
yes.
then what will happen? Module, INV, everything together. It will not understand anything. What I mean, white space ignored is you need to give a space here. But if you give 3 space, no problem. Do you understand?
Yes.
White space ignored means after the word module, you need to give at least 1 space. 1 space is enough. But if you give 10 space, that I am very sleepy, space. So you write your INV here. Okay, no problem. It will look bad, but no problem, it will work. But you need to give at least 1 space. This is the meaning of white space ignore. Do you understand? And it will expect that after the name, there will be a bracket. The software will expect that after the word module, then a space, then you write the name of the module, then you give a bracket. Now, if you write your module name as my space INV like this, then what is the problem? The software will think module, the name is mine. The name of the module is mine. Then after my there should be a bracket, but it will find another thing. So it will say it is an error.
Yes.
Okay, so what you should do is either you remove this space or put something here. Okay, but no space. You understand? It is more. I think it is more clear those who already took C, right? It's very clear because you did not take C. That's why this syntax looks very strange. But if you know C, it's very same. It's very much same as C. Okay. Try to understand. It's not difficult. Inshallah, it will be easy. Okay. That's why every time there is something same as C, I am saying it is same as C, so that it is easy for you. But if you don't know C, doesn't matter, C or HDL will be said. Right? Anyway, so here we have module number 1, 2 and 3. First module, what is the name? And 3. It is a 3 input AND gate. It is a 3 input AND gate. So input is A, B, C, output is Y. And see, there is a semicolon here. Okay, don't forget this semicolon. There is a semicolon here. Here, see, here there is a semicolon. Yes. Here for every line, you put a semicolon. Assign, I told you, for every equal sign, you write the name, the word assign. Assign Y equals A and B and C. Then AND module. So this module will calculate 3 input AND. This is the 3 input AND. Okay? This is the 3 input AND. What about this one? INV, it's inverter.
This is
Not gate.
name.
This is name. Module INV. INV actually short of inverter. Input A, output Y. One input, one output. assign y equals not a. This is not gate.
Why not?
It's a not gate, not inverter. A bar.
Yes, yes.
This is a bar. So this one is y equals a bar. This one is y equals a b c. This one a b c. This one is a bar. This one is in this module NAND 3. Here NAND 3 means 3 input NAND gate. So we are implementing a NAND. You remember NAND gate is in NAND, it is not AND, right?
Yes.
Not AND.
Yes.
So A and B with a NOT. This is NAND, right? A and B. Then if you take a NOT, this will give you a NAND,
Yes.
right?
Right.
This is you know. So if you want to do it using this module and this module, what you will do? First you need to do, say I have 3 ABC.
Yeah.
No, three input NAND I want to do. So what we can do? We first have to do AND,
Yeah. And
then have to do NOT. So for doing AND we have this. For doing NOT we have this. So first we will call this one, that will give us A and B and C. Then we will call inverter, that will do the
No.
NOT. Okay. So here you can see you are declaring a, you can say a gate, making a gate of type N3. Okay, N3 with a module name and gate.
What's Verilog and one?
why?
I will tell. N1 is a local variable, like a new wire.